70, 80, 90, 9. Hi folks, we're back. We're going to try to break something new. This time we've got some water bottles here. These are the cheap, real flimsy water bottles that just seem like they won't hold hardly anything. What we're going to do is we're going to pressurize these and see if we can burst them. We're going to try one of them still full of water, and another one we're going to do full of air, and you'll find out that the one full of air is a whole lot more dangerous, and we'll explain how that is. This third one, this is cold, and what we're going to do with that is I'm going to drink it. Okay, so one of the first things we have to do is figure out how we can pressurize those things. And what we're going to do is we're going to use an air compressor. But to do that, we're going to use one of these, which is a valve stem from a car, technically a Schrader valve. And we're going to drill a hole in the cap of one of these bottles and install this in there so that this will be on there and we can hook it up to our air compressor and pressurize it. So let's go do that. And here we go. Schrader valve installed in there. Drilled it, I think it was a 1/2 inch hole, pulled it through there, and this screws on like so, and check, make sure it's straight, and that should do the trick. Okay. Now let's go see if we can have some fun while not getting hurt. Okay, here's a good time to talk about why pressurizing with water is a lot safer than pressurizing with just pure air. Now, this is like a lot of the rocket companies you see nowadays. They have to pressure test their tanks, and they have to consider this just like we do. Let's talk a little bit about physics. In order to store energy, you have to be able to do work on something and pressurize it. In this case, if we push on water, water doesn't compress. So you may be pushing hard, really hard, but it doesn't move hardly any at all. So work is force times distance. So if you can push on something but it doesn't compress, there's no energy stored in it. Now air, on the other hand, if you push on it, it's going to compress. And you push more, it's going to compress more. And the more you compress it, the more energy you're storing in there. So when that tank bursts, if it's full of air, it releases all that energy in a big explosion. Now, if it was truly just water, since it didn't store hardly any energy at all, it's just going to split open, and it may spray a little water around a little bit, but it's not going to be a big explosion. And you'll see that when we do our test. So if you want spectacular, you do air only. If you want safe, you do water only. The test is still good. You're still pressurizing the plastic, and the plastic will stretch a little bit, and that stretching plastic will store some energy. So you will get some explosion, but not nearly as much as air. Okay, we're going to show you what we have set up here. Right now, we have this water bottle, and I topped it off so it's full of water, hooked up to a tire inflator. I have the handle taped with masking tape. I put it inside out, the masking tape inside out, so my handle's not all gooey. On the other end, we have this giant compressor, and what I'm going to do is turn the pressure down on here, way down, so that there's zero pressure out there. And then I'm slowly going to turn that pressure up while watching the gauge, and we'll see what pressure it is when it bursts, if we can get it to burst. I've done this test before, and some of these bottles can be pretty sturdy. Now for safety, I have this camera set up way back here, and I can zoom up on that without being close to it. So I'll start turning up the pressure on this and watch that bottle out there until it bursts. Okay, let's see what we can do here. Here we go, we're at zero pressure, starting to turn it up. Okay, I hear the bottle starting to creak. So it's getting a little pressure. We're up to about 10 psi. psi. 30, about 30 psi, which is about what a car tire has, which is a lot of pressure, and it's still doing fine. Okay, that's 40. 50. Okay, we're up to 60, which is getting up in the range of a pretty good mountain bike tire. Okay, 70. 80. 90. 100 psi. There, it went at about 110 psi. Okay, what happened on that is the Schrader valve came out of the cap, so the bottle didn't break, and that was up around 100, 110 psi. There's a little loss in the hose as some air's leaking out there, but it blew the Schrader valve right out of the cap, split the cap. So we didn't succeed in popping the bottle. So that goes to show you how strong it was. You notice when it gave way, there wasn't a loud boom or anything, but the bottle shot up in the air a little bit. Okay, I weakened that one a little bit by wrinkling it up a little bit because we're getting close to the limits of the compressor. Okay, let's try it again. 10, 20, 30, 40, 50, 60. There we go. Let's do it again. Ha! One more time. One more time, one more time. Okay. 10, 20, 30, 40, 50, 60, 70, 80, 90. Woo! That one was loud. Almost 90. Okay. Okay, there we go. So you have this versus the water bottle, one full of water, which blew the cap off. It didn't split down the side, but even if it had split down the side, it would have been just a little split, like when the lid came off. But with air, you can see the amount of energy that was involved in that. Pretty spectacular. Don't try this at home. You can get hurt. That last one hurt my ears, and I'm back here over 20 feet away from it, and it still hurt my ears. So anyway, there we go. 70, 80, 90, 9. Hi folks, we're